So once again, we are also now going to move to another subtopic as we started earlier. So we are now going to move on with logarithm. Logarithms. It is not new to you. You have been learning it since senior 2, senior 3, senior 4. Now here at A level, we are not changing anything there, but we're just advancing it as it is advanced level. We are developing more content on it. So I want you to be very careful as far as we are handling these logarithms. Let's be very attentive, let's cooperate, and where you need to ask, better send your questions, then we'll handle them as soon as possible. So what do you understand by the term logarithm? So there has been, some people have been dealing with logarithm, but they don't know what is a logarithm. What are logarithms? So we simply say logarithm. The term logarithm refers to the index of a given positive number base. You can write it. The term logarithm refers to the index of a given positive number base. Given positive number base. A given positive number base. That's what we normally talk about, what we call logarithm. Here we deal with positive numbers. We don't talk about negative. That's why I've emphasized with the word positive. Very, very important. Positive. We don't deal with log of negative 5, log of negative 9. You know, we are dealing with only positive, that one. So that's what happens to it. We can move on and say we consider a to power x. Remember what we are dealing with indices. A power x equals b. Provided that a is greater than 0. Provided that a is greater than 0. Provided that a is greater than 0, comma, b is positive also. B is positive. So you don't start with a when it is equal to 0, because it will be meaningless. As we say that we are dealing with numbers which are positive, but greater than what? 0. You cannot say that 0 is negative, so that's why we are also neutralizing it, that any number should be greater than 0. So in this case, the x is defined as the logarithm of b. So in this case, x is defined as the logarithm of b. Is defined as the logarithm of b to the base a, written as log of b to base a equals x. So this one is written as this. When it comes like that from that index, we write it as log of b to base a equals that number. Basing on the connection between the index and logarithm forms, so we are defining now connecting all those connectivities which we have been using, like from the rows of indices what we have been using. So the same is going to apply in these logarithms. That's why we started with indices. From indices, they are building us to logarithm. Basing on the connection between the index and the logarithm forms So we want to look at the connectivity, the relationship, things which are related to it, that they have the same thing which is in them, which is starting in them. That's what we want to look at them there, as we're going to be following more and more rules which are governing this. So following the same rules, like we have said that a power x equals b. This implies that log of b base a equals x. If we have a power 0, we said any number of 0 is the same as 1. Is the same as 1. What does it imply? It implies that log of 1 to base a is the same as 0. When you see log of 1 to any base, you just get a 0. So if you have a power 1, we said it's the same as a. What does it imply? If you have log of a to base a, automatically the answer is 1. So you have log a related to that base is the same as that. So we are going to look at laws of indices. Laws of consider, so I'm using the word indices because they have been connected on the theme. So you're going to say laws of logarithms. And here we're going to be proving them where they came from. So I want you to be very, very attentive where you are. So 1, if we have log of b to base c, or I can say maybe log of a, let me say log of a base b plus log of b to base c is the same as, when the bases are the same, we just multiply their logarithms. So this is the same as log of ab base c. Law number 2, if you have log of a base c minus log of b base c is the same as, when you are subtracting, we do the division. So we are going to say log of a out of b to base c. Number 3, if you have log of b power n base a, this is the same as n log of b to base a. So I'm going to prove 1. After proving for you 1, the rest you can even prove by yourself. So I want to do the proof. And I want you to be very, very, very attentive, because they will ask you, prove. Here in A level, we normally prove. We don't just gamble. We need to know the origin of these numbers, where they came from. So we are going to start with the proof for number 1. I can start by saying, let log of a to base c equals x. Let log of a to base c equals x. So where it came from the index power. This implies that a is the same as c power x. I can call this one as equation 1. Similarly, we also go to this part. We also say let log of b to base c equals y. So we're also going to say let log of b to base c equals y. Still, we apply the index form where it came from, like what you see in the applicability. This means that b equals c power y. This is the second equation. What if I say equation 1 times 2? Equation 1 times 2. Can we apply equation 1 times 2? So when we multiply a times b, we are going to get ab equals c power x times c power y. Then we still apply our laws of indices, which we have tried to elaborate to you from behind. So when you are multiplying numbers of the same base, we do the addition of the powers. So this becomes ab equals c power x plus c y. So when you reach here, what can we do? We taking log to base c, on both sides. You can say taking log c on both sides. So we are going to take that on. This becomes log of ab base c equals log of c power x plus y base c. So this power is brought here from that rule which I've already said. So this becomes log ab base c equals x plus y log of CC. But log of CC is the same as 1. Log of a number related to the base is the same as 1, like what we have already looked at here. Log of A related to the base is equal to 1. So what happens? We get log AB base C equals x plus y. But do we know x? We know our x. Our x is already log of A base C, and our y is already log of B to base C. So we can write it very well. We say log AB base C is the same as log of A to base C plus log of B to base C. So this one is already being approved. So I have already shown to you where it came from. So I would request that all of you go ahead and do the needful by proving law 2 and law 3, because you are going to be applying them in all the concepts which you are going to be using. So I request that be very, very attentive when you're doing this and practice yours. So as we are going to be proceeding to another step. Has it come out well?